Okay, so let us solve an Atlas machine or a pulley problem that is with the setup similar to this one. So for M1, or the mass number 1, is placed on top of a table. It is connected by a string to M2. So just like in the previous assumption, we will assume that the pulley is frictionless, the string is massless. So our mass 1 is 25 kilogram, our mass 2 is 40 kilogram. And we are asked to find the following, So I need to find, you need to solve for the following. So number 1 is the F net, the total forces involved in the system. Number 2, the total mass, MT, right? Number 3, acceleration of the system. Number 4, the tension present in the string of the system. Okay, so just like in the previous problem, we need to determine first the weight of the masses. So weight for mass 1 and then the weight for mass 2. So let us have here our weight 1, M1 and G. So take note that in computing weight 1 or the respective weights, we also have to use the respective masses. So for just like weight 1, we will use mass 1. For weight 2, obviously, we will use the mass 2. And then we multiply it by G, or the acceleration due to gravity. So to determine weight 1, we have M1, which is 25 kilograms, multiplied by 9.8 meter per second squared. And let me just pull up my calculator. So that's 25 multiplied by 9.8, and that will give us 245 newtons. Alright, 245 newtons. For our weight 2, okay, we have mass 2, that is 40 kilograms, multiplied by 9.8 meter per second squared. So that's going to be 40 times 9.8. That gives us 392 Newton. 392 Newton. So since we already have our weight 1, okay, and our weight 2, as you can see here, we need to examine first M1. Right? So you'll see that the forces involved in this setup, okay, let me color it, in this following setup, alright, M1 or the mass 1 is placed on top of a wooden or a table, right? So the weight or the force exerted by M1 is actually directed downward, right? So that is where the weight is, or rather the force. Let me just erase this. The force or the weight, okay, which is equals to F also. So now, there is a corresponding force that is acting on the system or this system. And that force is what we call the normal force, which is directed upward. Okay, so this is the normal force. So if the normal force is positive and the weight that is directed downward is negative, we're just subtracting a positive to the negative number, which will give us a 0. Right? So Fn minus W will just simply give us 0. So we can say therefore our weight for our system 1, this is our system 1. Okay? Let me just fix that. So let me just fix this one. So yeah. So again, this is our system 1, right? System 1, and this is our system 2. So let me just change the color, so you'll know the difference between system 1 and system 2. Okay, so this is our system 2. Okay, now going back, since the resulting value for force is 0, we can therefore say that our weight 1 can be 0. Alright? Why did we say that it is 0? Because the forces acting in system 1 is actually 0. Okay? They are balanced. Okay? They are balanced. And also, the force existing in this setup is only along the horizontal. not in the vertical. So this explains why we have a zero amount of force in the vertical direction. So ang concern natin ay yung force lang na papunta dito. Okay, not the upward or downward force. So we can say that the force in the vertical, okay, is equals to 0. Our weight therefore in the vertical is also equals to 0. Alright? Now, in order for us to determine F net, or the total force present in the system, 1 and 2, we just simply subtract the smaller value of weight to the bigger value of weight. So if our W1 is 0, okay, not this one, our W1 is 0, therefore we can just have 392 Newton minus 0, then that will give us 392 Newton. So this is our F net. Again, it is 0 because we're not interested in vertical forces exerted by M1. We are only interested to the horizontal forces that it will be exerted against M2. Alright, so this is our F net for the system 1 and 2. Okay, so we're done with number 1. Let's now solve for number 2. So this is our number 1. Our number 2 is the total mass. Alright, so or rather let's make it let's make it a small one so that we have a uniform labeling similar to this, so we have small letter M and then total capital T. So that is just the sum of M1 and M2. Alright, so our M1 is 25 kilograms plus our M2, which is 40 kilograms. So this will give us 65 kilograms. Alright, so 40 plus 25 is 65 kilograms. So this is our M total, meaning the total mass present in the system is 65 kilograms. Alright, now let us solve for acceleration. So for acceleration, keep in mind, gentlemen, that the acceleration that we need to solve is the acceleration for the entire system, meaning the acceleration of S1 and S2. So the acceleration of mass 1 should be the same with the acceleration of mass 2 because they are connected with the same string. Alright, so in order for us to solve this, we can use Newton's second law, or we can just simply derive from this. Remember that this came from F is equals to M times A. No? Since let us use this since this is our practice. So F is equals M times A. For acceleration, we have to use the net and then the M total. Again, they have the same acceleration. M1 and M2 should have the same acceleration because they are connected to the same string, with the same string. So F net and mass total. So our F net is 392 newtons. Our mass total, or total mass, is 65 kilograms multiplied by acceleration. So again, we do not want the 65 kilograms beside acceleration, so we need to remove it by dividing 65 kilograms on both sides of the equation. So this is kilogram. So we remove this or cancel the numerator and denominator. What is left now? So let me rewrite it. Acceleration is equals to 392 Newton over by 65 kilograms. Okay? So keep in mind that acceleration has a unit of meter per second squared. Now where did we get where can we get the meter per second squared? It's basically from Newton, because we all know that 1 Newton is equivalent to kilogram meter per second squared. So we can see here that the kilogram can be cancelled, and what will be left is meter per second squared. Alright? So let's grab the calculator. So it's going to be 392 divided by 65, and that will give us 6.03 meter per second squared. So this is 6 0.03 meter per second squared. So this is our acceleration. Again, the acceleration for M1 and M2 are just the same because they are connected with the same string. Alright. For number 4, the tension, okay, we can do this in two ways. We can use system 1 or system 2. Okay, I already drew the arrow here. Okay, for object that goes down, alright, so we can see the arrows are pointing down. That means mass 2 is going down. Therefore, we will use subtraction. So, tension is equals to weight 2 minus F2. Alright? Now, if we're talking about the other operation, let's say the object is going up, no? So, we will use a positive operation. Okay? So, for tension 2, we selected system 2 in order for us to check the tension that is present in the string. So, we just simply plug in the value for W2. We have 392 Newton. And our F2 is not yet computed. So, let's compute the F2 for this system. F2 is equals to M2 times A. And that will give us 40 kilogram multiplied by 6.03 meter per second squared. Our F2 therefore, so let me just erase this, 40 multiplied by 6.03, that will give us 241 Newton. So this is our F2. So we will use this to subtract from 392. No? So let me just move this one so I can write properly. Let me just move the entire computation here. Right? So that's 392 minus 241 Newton. Right? And that will give us, okay, so 241.2. Alright, so 241.2. Let me just again fix that one. So it's 241.2. Ayan. So where's my pen? It's here. Okay, 241.2. And let me arrange this one also. It's 241.2. Oops, sorry. It's 241.2. There. Okay. So let me just pick up my calculator. So that's going to be 392 minus 241.2. And that will give us 150.8. Okay. So it's 150.8 Newton. So this is our computed tension. So keep in mind, gentlemen, that tension 2, this is tension 2, should be equal to tension 1. Right? Since they have the same string. Kailangan ganyan. So whatever the value of tension 2 should also be the value of tension 1. Okay? So we can check it using tension 1. System 1. Alright? So for tension 1, okay, we can have W1, this time it's plus, and then F1. Alright? So W1 is equals to 0 by 0 because according to our idea, Fn cancels with mg, right? Or weight. So this will be 0 plus what is F1. We do not have the value for F1 yet, so let's compute it. So let me use a different ink. So F1 is equals to M1 times, oh sorry, that is supposed to be A. Okay? M1 times A. So M1 is 25 times 6.0. 6 point, oh, that looks like a 2, but it should be 6. 6.03. Forgive my handwriting. It's very difficult to control. Right? So that will be 25 multiplied by 6.03. So that's 25 multiplied by 6.03, and that will give us 150.75. So it's 150.75 Newton. Alright? So if you will check it, so this is 150.75 Newton. So 0 plus 150.75, we can have 150.75 Newton, or we can express it at as 150.8 Newton. So they're just the same, right? So we actually follow T2 is equals to T1. So that's how you solve for the F net, total mass, acceleration, and tension of this setup.